All right, in example 10, we're going to simplify some radicals. I'm going to use these properties right up here. We used actually one in the previous example. We can split up radicals under multiplication and division. So if we're multiplying inside, or if we're dividing inside a radical, we can split up that radical. And we can use that to help us simplify these. I'm going to show you two ways to do it. One using the properties that we just went over. And another way, which might be kind of a little bit simpler. So we always start, when we want to simplify radicals, by factoring the number inside. So 48, make a little factor tree here. This is 4 times 12, and 12 is 4 times 3. We could go further, but this will actually do pretty well for us at this point. So we've got 4 times 4 times 3, or the square root of 16 times 3. And I'm writing it this way to use that property that says when we have a product inside, we can split up that radical. So I'm going to split this up as the square root of 16 times the square root of 3, and 16 is a perfect square. Square root of 16 is 4. So this simplifies to 4 times the square root of 3. Now another way to do this, and I think this might be just a little bit simpler, again we start by factoring. So the square root of 48 is 4 times 4 times 3. And here's the rule is you look at the index of the radical, and the index is sort of the number that is sort of right here, that little number. When no number is written, it's a square root, which means really it's a 2, right? We have a square root here. And so with square roots, as long as I have a pair, if I have 2 of the same factor inside, then I get to bring those out. They become 1 factor outside, and then they both disappear from inside the radical. So 2 4s inside becomes 1 4 outside, and now both those 4s are gone and we're left with 3. Same thing that we got with the other method. In part B, we have the cube root of 40. So again, we're going to start by factoring. 40 is 4 times 10. 4 is 2 times 2, and 10 is 2 times 5. So this is the cube root of 2 times 2 times 2 times 5. Now because this is a cube root, I need to have 3 of the same factor inside to bring 1 out. So we have 3 2's. Those 3 2's in the radical become a single 2 outside. Now all these 2's are gone from inside the radical. We have 2 times the cube root of 5 is all that's left inside. In part C, we have sort of a different scenario here. Certainly 3 is already factored. The problem that we encounter is that square root of 3 is in the denominator. Now we do not want to have radicals in the denominator, and so what we're going to do to fix this problem is we say, okay, the problem is that we have a square root of 3 in the bottom, and I can fix that if I multiply by the square root of 3. And just like when we worked with fractions before, I'm allowed to multiply that by the square root of 3 as long as I also do the same thing on top. So now we have on top 1 times the square root of 3, or just the square root of 3. On the bottom, we have the square root of 3 times the square root of 3. And by definition, if I take the square root of a number and multiply it by itself, you just get the number inside. So we have 3 on the bottom. And this is simplified. When we look at this fraction, it might look like perhaps we could cancel those 3's, but we cannot cancel the 3's because one lives inside a radical and the other one does not, and that means they're off limits for canceling. And in part D, we have a fraction inside a radical, and we can start out, if possible, now this isn't always the case, but here we might notice that 3 goes into 75. We can reduce that fraction first, and that'll help make this easier. So 75 divided by 3 is 25, so we can reduce this as the square root of 1 over 25. And now looking at this, we have a fraction inside the radical. We can use that property that says we can split up a radical over division. So we have the square root of 1 over the square root of 25. These are both perfect squares. Square root of 1 is 1, square root of 25 is 5, and there we are simplified. In part E, we have some addition happening. So one thing we have to be very clear of is the fact that we cannot split up a radical over addition. And in fact, we could see that we have 6 squared inside, but we can't bring out a 6 because we have addition here. Addition sort of ruins all of our nice simplifying rules. So what we have to do first is actually evaluate this expression that's inside the radical. So 6 squared is 36 plus 18. 36 plus 18 is 54. So we have the square root of 54. Now what we'll do is factor the 54 and see what we can do as far as simplifying from here. So 54 is 2 times 27. 27 is 9 times 3. And 9 is 3 times 3. So the square root of 54 is the square root of 2 times 3 times 3 times 3. This is a square root again, so we just need 2 of the same factor to bring 1 out. I've got a pair of 3's right here. Those become a single factor of 3 outside. And what's left inside is a 2 and a 3, so 2 times 3 is 6. And this is the simplified radical form. In part F, we've got a bunch of stuff going on here, but everything is multiplication. We've got some exponents and things that are multiplied. There's no addition or subtraction, and that makes things nice and easy. So what we're going to do first is I'm going to factor this 24. 24 is 3 times 8. 8 is 2 and 4, and 4 is 2 times 2. So we have a cube root of 2 times 2 times 2 times 3. And then we have an x to the fourth, and I'm actually going to write that as x cubed times x, just to help make our next step a little bit simpler. And then we have times y cubed. Now, perfect cubes can come out. We know when we see something to the third power, that's, for example, right here, this is 3 factors of x. So that x cubed inside will become a single x outside. Same with this y cubed. And we have these 3 2's. So what we're going to bring out is a 2, an x, and a y. And when you bring out multiple factors, they're actually factors, so they'll be multiplied. We have 2x, y. And we have the cube root of, and what we have left inside is a 3 and an x. So our simplified form is 2xy times the cube root of 3x.